So now moving on to the compartment design of a switchgear, HV switchgear. So each compartment is described as, from design perspective, either it will be fixed type, that is you cannot rack in, rack out the circuit breaker. Removable, you can entirely remove the circuit breaker component from the switchgear. Withdrawable, you can withdraw it. Extractable is some part can be extracted. Now, accessibility of compartment as per IEC 62271 clause 8.2.2. That is, IEC clearly specifies how can I access my circuit breaker in a HV switchgear based on the design. So firstly, interlock controlled accessible compartment. So we should know that, for racking in, racking out, there are two types of, interlocks that are ideally provided in any switchgear. First is called a mechanical interlock. Secondly, we call it an electrical interlock. So mechanical interlocks are the basic functions which we know. Let's say, for example, we want to open the wardrobe, we have to enter the keys, open it, and then only the wardrobe, opens up. Right. So similar way, there are some specific mechanical interlocks which are already predefined and mentioned in the standard, which the manufacturer has to abide, part of the design. And apart from that, there are optional lot of electrical interlocks which we can provide in the switchgear, right, with the auxiliary contacts for the safety of the circuit breaker operation in the switchgear. So first is called the interlock controlled accessible compartment. Interlock control means there is an interlock, means if this interlock is there, you cannot open. And if this interlock happens, then you can open, right? Then there is a called procedure based accessible compartment. So in order to access the circuit breaker compartment, there is some procedure. Let's say first of all, you have to switch off the TNC switch. You have to close the breaker. Then you have to do a push button switch. Then only you can access it. For example, so this is called a procedure based accessible compartment system. Then there is a tool based accessible compartment. So you have a lot of tools for racking in, racking out, circuit breaker handling tools. So with those tools only you can access the compartment. And finally, non-accessible compartment. So there are some compartments which you cannot access by bare hand, right? Irrespective of any interlock you keep in the system, right? So these are the four types of interlocks or accessibility compartments that are defined in the IC standard. So what are the enclosure protection that can be provided as part of your HV switchgear design, and what are the bare minimum ingress protection that manufacturer needs to provide as part of the switchgear design? So IEC mentions minimum IP2X. So the dust protection is 2, and X means the water protection is not tested. So this is the minimum degree of protection that any HT switchgear manufacturer has to provide, bare minimum, right? Where X shall be minimum of value 1, or X basically defines which is not tested, right? Now, if you require IP4X, you require IP41, you have to specify the same in your specification and data sheet. And manufacturer, if it is possible, if they have same manufacturing line of assembly, they can offer you the same. But for that, you have to take and ask a type tested certificate from the certifying authority, which is a valid type tested report, to specify that really my switchgear which I am procuring from the manufacturer is really certified for that IP certification. ANSI mentions minimum type 1 enclosure is provided. This type 1, type 2, 3, 4, 4R, everything is defined in NEMA ICS 6. So this is the standard. For example, IC 60529 is the standard for IP ratings. Similarly, NEMA has ICS 6, which specifies the NEMA protection ratings for the enclosures. Now, what are the specific current? We have seen the specific voltages, short circuit withstand time, short circuit withstand current. We have seen the power frequency withstand voltage, lightning impulse withstand voltage for a specific voltages. Now, it's also important to understand what are the standard current ratings that the manufacturer can offer as specified in the IEC and IEEE standard. So as per the IEC 62271 part 200 standard, clause number 4.4.1, the standard values of rated current are 630 ampere, 800 ampere, 1000 ampere, 1250 ampere, 1600 ampere, 2000 ampere, 2500 ampere, 3150 ampere and maximum 4000 ampere for HT switchgear. Whereas IEEE C3720.2 clause 4.5.4.2 specifies only 3 available options to select from. First is 1200 ampere, second is 2000 ampere, and third, the maximum which you can take or ask the vendor is 3000 ampere. Now lightning arrestor, yeah. So very important, any HT switchgear is the first switchgear which will be, let's say, coupled to your grid or the upstream system. So that's why any lightning surge which is happening on the upstream, the HT switchgear will be very much vulnerable to that. So as a result, always on the incomer circuit from where my cables are entering to the HT switchgear, the incomer circuit should ideally have a lightning arrestor which is very properly designed and rated for your system. So that's why we have to know the rated voltage of any lightning arrestor is always based on the system voltage of your HT switchgear. And the discharge current rating as per the calculation, the standard ratings are 5, 10, 15 and 20 kiloampere respectively. And disconnecting switch, if you are providing as part of your HT switchgear, the rated voltage and current will be as per the incomer rating, mind you. Now the peak value of short time current and closing capacity. So peak current is basically nothing but the making current, right? So breaking current is basically after few cycles has elapsed, the the relay gives us command and the circuit breaker contact starts opening. That's the breaking current. But when a fault has happened, that time the circuit breaker will see the fault, but it should not open until a command is issued to it. And that time the magnitude of the current is very high, and that is called the peak value IP or making capacity of a breaker. So as per IEC 62271-200 clause 4.6, the peak value or making capacity of an HT circuit breaker is 2.5 times of breaking current at 50 Hz and 2.6 times the breaking current at 60 Hz and 2.7 times for some special cases. Okay, so let's say if your making current, my mistake, if your breaking current is 10 kiloampere at 50 Hz, the making current will be 10 into 2.5, which is 25 kiloampere for 50 Hz system. Similarly, let's say for ANSI standard where 60 Hz is very normal, if your breaking capacity of the breaker is 10 kiloampere, then the making current will be 2.6 times, that is 26 kiloampere at 60 Hz. Similarly, for IEEE C3720.2 clause 5.4.3, the peak value of short time withstand current is equal to 2.6 times ISC at peak value. Now you can understand why they have given this 2.6, because 2.6 ISC at 60 Hz. And most of the countries which do follow the IEEE and ANSI standard falls or their systems are designed for 60 Hz operation. So that's why they have fixed it to 2.6 Hz, 2.6 times. Rated short circuit duration. So this we have already discussed in last slide. Now very important point is internal arc classification. So in most of the American organizations or American companies, usually the maintenance of a switchgear happens online when the panel is live. So understand, in that time, if an arcing fault happens, the operator who is working is very much under the influence of a arc fault, right? So as a result, IC has defined the internal arc classification for all HT switchgear panels. So with reference to IEC 62271 part 200 clause 8.3, IAC or internal arc classification shall be as below. So there are two types of accessibility that is defined. First is accessibility type A and accessibility type B. Now what is accessibility type A? A refers it is restricted to authorized personnel only. So any person, let's say wearing a PPE kit or having an access, will be only allowed to access the switchgear. Whereas accessibility type B refers unrestricted accessibility. Anyone can access the switchgear, including that of general public. So for example, let's say some HT switchgear are part of which are installed maybe beside the road, very near to the road. So many times animals or any human being unintentionally may get close or get interfered with the HT switchgear, maybe unintentionally. So those will be for part of the accessibility type A, but usually which are part of installed in a switchgear or substation room with a restriction of access falls under the category of accessibility type A. So according to the accessibilities A and B, the following codes are used for internal R classifications. So first is called F. F is called front. Alphabet L is called lateral. Lateral means sideways. And R is called the rear side. Why it is mentioned? Because any three-dimensional panel you can access in from the three ways ideally. Sideways, which is lateral ways, front from the front, and there is R. Now someone can argue why not from the top? Now usually the HT panels have a height greater than the standard human height, operating height. So usually no person will intentionally jump onto the top of the switchgear to access it. Usually it will be from either front, side or the rear part. So that's why F, L and R. Now this accessibility type A and B I have defined for, you can see metal enclosed switchgear except pole mounted, which are not pole mounted. But if there is a pole mounted switchgear which is installed intentionally in a pole, those forms are accessibility type C. So accessibility restricted by installation out of reach. So here for public and animal safety, the switchgears are installed at a much height greater than the reach of the human being or animals for the safety point of view. So the minimum admissible height of installation for each switchgear shall be stated by the manufacturer. So this is manufacturer standard, and as part of the requisition or offer, they provide the accessible or admissible height for the HT switchgear. Now, apart from IAC classification, the partition type is a new concept that has been introduced in the IEC standard. So partition type is basically partition with regards to the barrier between live part and opened accessible compartment in accordance to 62271-200 clause 8.2.4. So let's say if I have opened the switchgear also door, many of the equipment may be live in the rear section, for example. So therefore the partition type classification becomes very, very important. So the two types of partition classes that is defined in ICR, PM class and PI class. Now what are those? Let us see. So I'll see it in the next slide. So in reference to IEC 62271-200, LSC is loss of service continuity. So this is another new concept. So what is LSC? LSC is loss of service continuity when there is an opened main circuit compartment. So if the main compartment or the main circuit breaker is opened, so there will be a loss in the service continuity. So the downstream of your system may have the discontinuation of the power service. So this is done to understand, that is, up to which extent of busbar cable may be left energized but not necessarily with power flowing through them. Okay, so there are two types of partition classes. My mistake, yeah, that loss of service continuity defined in the IEC standard. First is LSC1 and second is LSC2. LSC2 is further subdivided into LSC2A and 2B. So let us see what is LSC1. So the 1 denotes that there is no service continuity, at least for one functional unit other than the one containing the opened main circuit compartment. So what it is trying to tell, that suppose the main circuit compartment is opened for a particular reason. Now one will say that there is no service continuity, at least for one functional unit, other than one containing the open. So one which you have opened, apart from that only maximum one will have a loss of service continuity. Apart from that, the others may remain charged or energized. LSC2 under we have 2A. So 2A denotes that there is no service continuity of the functional unit containing the opened main circuit compartment. So the main circuit compartment which you have opened, there will be no service continuity of the other functional unit which has the main compartment or main unit open. 2B refers to the service continuity applies to other compartments of the functional unit containing the opened main circuit compartment. So even if you have opened the main circuit compartment, some part of the main circuit will remain energized, and apart from that, part of this main compartment, all the other functional units may remain energized. So there is no guarantee that that has been disconnected. Now enclosure category which I was defining. So enclosure category defines the degree of protection to the enclosed conductor or equipment that will provide, a personnel to safeguard during the contact with the accident contact with the life part. So first of all, category A enclosure. So category A enclosures are intended to provide a degree of protection against contact with enclosed equipment. So the person can contact the enclosed equipment in ground level installation subject to deliberate unauthorized act by member of the unsupervised general public. Category B mentions intended for use in installation not subject to deliberate unauthorized act by member of unsupervised. So general public cannot access those, only can be installed or accessed by a proper authorized personnel. Okay. Category C is intended to provide a degree protection against contact with enclosed equipment in secured installations, intended to be accessible only to the authorized quality person. So here, the installation will also happen in a secured room, as well as the person who can access it has to be also a trained supervision and a qualified authorized person. So these are A, B, and C types of enclosure category defined in IEEE 37.20.2. So this is exclusively defined in IEEE standard and not mentioned in the IEC 62271 standard. That's all part of the HV switchgear. Hope you like the presentation.